Thank you.
Good morning, everyone. Today I'm going to present a paper entitled A Case-Based Reasoning Approach to Support the Application of Eco-Design Guidelines. In particular, in this paper we describe the development step of the CBR tool, which is being created as part of the G.EN.ESI project. In this paper are presented the theoretical assumptions of the tool, and there is not a complete correspondence between these theoretical assumptions and the tool developed for the G.EN.ESI project due to some complexity related to the development of the tool, in particular to the knowledge management. The CBR tool we propose in this paper has the aim to support designers in the design process, and in particular in the consultation of eco-design guidelines and the company eco-knowledge. By the consultation of these guidelines and knowledge, designers are guided in the product modification in order to improve the product sustainability. A lot of general guidelines exist in literature. They are valid for a wide range of products, but they rarely provide a tangible support for designers during their product development process. And there are currently no methods and tools for the managing of these eco-design guidelines and of eco-design knowledge. So we have identified 5 steps for the tool development. The first one is the product modular analysis. Then we have identified a list of some standard components for each product analyzed. Then we have derived eco-design guidelines from the literature, and we have classified them into some different typology of guidelines. Then we have defined and classified the company knowledge, and we have tried to define an efficient system for the consultation of this knowledge and guidelines. The first step was the modular analysis for 3 household appliances: the cooker, the washing machine, and the refrigerator. The objective of this modular analysis is to describe each product through a schematic structure in order to define a list of standard components for each of these products. In particular, we have described standard component. We have identified standard component for cooker, washing machine, and refrigerator. These are the modules retrieved for the cooker case. And then we have defined standard component as those components that can be retrieved in different products. For instance, for the control panel module, in the case of the cooker hood, we have 3 standard components: the chimney, the cover, and the static panel, that is possible to find in all different models of different cooker hoods. Then we have defined and classified the eco-design guidelines. We have retrieved these guidelines from the literature. It is possible to assume that a high number of eco-design guidelines exist, and that they often provide to designers only general indications. The main consequences of these assumptions are that there is no an efficacious consultation of these guidelines by designers, and there's no an effective translation of them into design choices. In order to make eco-design guidelines more useful for designers, we have classified these guidelines according to the life cycle phases to which they are referred, the objective they allow to reach, and the standard component to which each guideline is connected. And also we have classified eco-design guidelines in eco-design guidelines related to products and components. In particular, the guidelines related to component can be divided into general and specific guidelines. The general guidelines provide suggestions useful to understand how designers can improve the product in terms of environmental sustainability. The specific guidelines derive from the EUP directive, and they are associated to specific component of a specific product family, while the guidelines related to products are general guidelines that provide indication that can be referred to the entire product. Then the first step is the knowledge definition. We have defined the knowledge as all the choices made by designers during the design process of a product. These choices can be related to the material selection, to dimension, to production processes, and also designers can memorize also the environmental impact related to these choices. This environmental impact can be retrieved by analysis, like for instance simplified life cycle analysis or complete life cycle analysis made on the product. Thanks to the knowledge, designers can consult the correlation between the design choices they have made in the past and the environmental impact of these choices. And this possibility allows to understand how to modify a component or a product to improve its sustainability. Of course, the tool functionalities will provide increasingly support as more data is stored in it. So the use of the tool allows to have a knowledge that designers can consult in future experiences. We have classified the knowledge and the eco-design guidelines in order to link them each other. In particular, both eco-design guidelines and past design choices are related to the same attributes that are the life cycle phase, the objective they allow to reach. And these links allows to filter eco-design guidelines and knowledge according to these specific attributes, and this offers to the designers an immediate way to understand how modify products in order to achieve some objectives. This is the tool architecture. It's composed by several modules. The first one is the CBR Intelligence Engine, which includes two sub-modules: the product structure manager that allows to manage the product structure, and the database link, in which connects the knowledge and the company and the guidelines DB. The second module is the graphical user interface that allows the user to insert all the information needed to the tool, in particular the product structure and the knowledge. Then the knowledge and guideline indication, that is the module which displays the output of the tool, the eco-design guidelines and the knowledge. And the knowledge and guideline DB, in which are stored all the guidelines and all the company eco-knowledge. In conclusion, the aim of this paper is to propose a new approach to support the product design and development of to support the product design in order to develop products with a high level of sustainability. And the proposed approach tries to overcome the difficulty in the application of eco-design guidelines during the design process. Thank you.